Dear students, the next session is simple numerical on Freudensteins equation on 4-bar mechanism. So let us start with a simple numerical problem number 1. A 4-bar mechanism is required such that the input and output angles are coordinated as given in table. Synthesize the 4-bar mechanism. Input crank angle, so which is given as 30 degree, 50 degree, 80 degree. The output follower angle, which is given as 0 degree, 30 degree and 60 degree. So we have to synthesize the 4-bar mechanism. So the input angles at 3 positions and the output angle for 3 positions are given in the problem. So let us solve this problem. So generally we know that the displacement equation given by Freudensteins for 4-bar mechanism, which is given by this equation, which I already derived in previous session. So which is given as k1 cos theta 4 minus k2 cos theta 2 plus k3, which is equals to cos of theta 2 minus theta 4. Now we have to substitute for the first position angle, the second position angle and third position angle, the corresponding input and the output follower angle. So if I substitute for first position, so the value of the input crank angle, it becomes theta 21 and the corresponding output follower angle, it becomes 41. So this equation, it remodifies as k1 cos theta 41 minus k2 cos theta 21 plus k3, which is equals to cos of theta 21 minus theta 41. So you substitute the value of 30 degree and 0 degree into this equation. So if I substitute that, we'll get this equation. You simplify it, so we'll get k1 minus, so cos 30 degree 0.866 times of k2 plus k3, which is equals to cos 30 degree, again we'll get 0.866, called as equation number 1. Again substitute the second position, so that is 50 degree and 30 degree. So 30 degree, 50 degree, so when you substitute it, simplify it, so we'll get, so 0.866 times of k1 minus k2 into cos 50 degree plus k3, which is equals to cos 20 degree, called as equation number 2. Similarly, substitute for the third position angle, 80 degree and 60 degree. So substitute it and simplify it. So you call that equation as 3. Now for these 3 positions, we got 3 equations. Now in these 3 equations, the unknown terms are k1, k2 and k3. So solve the 3 equations, equation 1, equation 2 and equation 3. We will get the values of k1, k2 and k3. So the value of k1 will get 1.8321 and the value of k2, it is 1.4294 and the value of k3 as 0.2718. Now assume the length of any one link, say as A, as unity, that is the value of A, which is equals to 1.0 unit. So I am assuming here because I have to synthesize a 4-bar mechanism. So in order to find out the dimensions of each link, so we have to assume any one of the link dimension. So here I assumed A, which is equals to 1.0. So we know that the value of k1, which is given as d by A. So you know value of k1, it is 1.8321. The value of A, we assume it as 1 unit. So easily we can find out the value of d. So therefore, the d, which is given as A into k1, so which is equals to 1.8321 units. Similarly, so we know the value of k2, which is given as d by c. So you know value of d, it is 1.8321 and the value of k2, we got it is earlier, so 1.4294. So on substitution, so we'll get value of c as 1.2817 units. Similarly, the value of k3, which is given as a square minus b square plus c square plus d square by 2 times of ac. So in this equation, the value of k3 is known, right? So the value of A, it is assumed as 1 unit. The value of B, so we don't know, this we have to calculate. C you know, so it is 1.2817. D, so it is 1.8321. So 2 times of AC. So substitute everything, you find out the value of B. So if you find out the value of B on simplification, we'll get 2.3039 units. So therefore, the length of various links are A is equals to 1 unit, B is equals to 2.3039, C is equals to 1.2817, and D is equals to 1.8321. So this is what the dimensions of the various links in a 4-bar mechanism, okay, for the 3-position analysis. So let us start with one more problem. So synthesize a 4-bar linkage using Freudenstein equation to generate the function y is equals to x to the power of 1.5. So it is a function is given. So y is a dependent variable, x is independent variable. So for the interval 1 less than or equal to x less than or equal to 4. Stop. The input crank angle is to start from theta 2 equals 30 degree and is to have a range of 90 degree. So the input crank, it will start from 30 degree and the range. So that is the difference between final and initial angle. So the range is given 90 degree. Take 3 accuracy points. So also take output crank angle from 0 to 90 degree. So the output crank angle, it will vary from 0 to 90 degree. So we have to synthesize the 4-bar mechanism for 3 position or the 3 accuracy points. Okay. In the previous problem, directly has given the angles, so we directly substituted. But here, so the output crank, it always depends upon the input by a certain function. So that is y, which is equals to x to the power of 1.5, where the value of x, it varies between 1 to 4. And also the input crank angle is given. So at the starting it is 30 degree and the range of that, it is 90 degree. The output crank angle he has given 0 to 90 degree. So this is the given data. So let us solve this problem. So go to the solution. So given, so the initial position, okay, so x naught, so x, it varies from 1 to 4. So x naught, which is equals to 1, x of n plus 1, so it is 4, and number of accuracy points he has given it as a 3, so n, it becomes 3. So therefore j, it will be 1 comma 2 comma 3. The accuracy points according to Chebyshev spacing, which is given as xj, which is equals to a minus b into cos of pi into theta j. We know that the value of a, which is given as half times of x of n plus 1 plus x naught, which is equals to x of n plus 1 is 4, x naught is 1. So 4 plus 1 divided by 2 will get 2.5. Similarly, b is equals to half times of x of n plus 1 minus x naught, which is equals to 4 minus 1 divided by 2. So we'll get 1.5. Also, the value of theta j. So theta j, which is equals to 2j minus 1 by 2 times of n. So where the value of j, it varies from 1 to 3. Now let us substitute the value of j, which is equals to 1. When j is equals to 1, so this it becomes theta 1, which is equals to 2j minus 1 by 2n. So in the interval j is equals to 1. So which is equals to 2 into 1 minus 1 divided by 2 into 3, which is equals to 1 by 6. Similarly, when j is equals to 2, so the value of theta, it becomes theta 2. So j, it is 2. So 2 into 2 minus 1 by 2 into 3 will get 3 by 6. Similarly, substitute the value of j, which is equals to 3. So we'll get theta 3 as 5 by 6. Now, the accuracy points. So xj, which is equals to a minus b into cos of pi theta j. Now, I will substitute the value of j. Okay, so when j is equals to 1, so this equation, it becomes x1, which is equals to a minus b into cos of pi into theta 1. Theta 1 we already found out this. So a already we got, b is also known, pi is also known. So everything we substituted. So a is 2.5, minus b is 1.5 cos pi into theta 1 is 1 by 6. So we'll get 1.20. Similarly, when j is equals to 2, so x it becomes x2, so theta it becomes theta 2. So the value of theta 2 is 3 by 6 and the rest it remains same. So we'll get the value of x2 as 2.5. Similarly, substitute the value of j as 3, we get the value of x3 as 3.799. So once you get the values of the positions of the x1, x2, x3, we need to calculate so the values of y1, y2, y3. So x is independent variable and y is dependent variable. So y it always depends upon the x1, x2 and x3. So we know that the output link function which is given as y is equals to x to the power of 1.5. So therefore when x is x1, so y it becomes y1. So y1 which is equals to x1 to the power of 1.5. So x1 is 1.20 whole to the power of 1.5, we'll get 1.314. Similarly, when x is equals to x2, y it becomes y2. So y2 which is equals to x2 to the power of 1.5. So that is 2.5 whole to the power of 1.5 which is equals to 3.953. Similarly, y3 which is equals to x3 to the power of 1.5 which is equals to 3.799 to the power 1.5 which is equals to 7.404. So we got the corresponding output link functions. Now let the starting value of input function, I will represent it as xs which is equals to 1. So this is given in the problem, that is the value of x it varies from 1 to 4, that is 1 less than or equal to x less than or equal to 4. So that 1 I will take it as a starting value of input function which is represented as xs which is equals to 1.0. Similarly, the final value of input function xf it is which is equals to 4.0. This I will take it as a starting value and this I will take it as a final value. Both are input functions. Now once you know the input functions, I will calculate the corresponding output function. Therefore the corresponding value of output function corresponding to this which is represented as ys which is equals to xs to the power of 1.5. So xs is 1 to the power of 1.5 which is equals to 1.0. Similarly, for this function I will calculate the final value of corresponding output function, so which is represented yf which is equals to xf to the power of 1.5 which is equals to 4 to the power of 1.5. So we will get the value as 8.0. Now let the input crank angles corresponding to three accuracy points x1, x2, x3 be theta 21, theta 22 and theta 23 respectively, and also the corresponding output crank angles be theta 41, theta 42 and theta 43 for y1, y2, y3. Let the variables x and y be related to input crank angles theta 2 and output crank angle theta 4 respectively through the relations. So this is the relation, so which gives the it is related between the variables x and y and the input and the output angles. So which is given as theta 2j which is equals to theta 2s plus delta theta 2 by delta x xj minus xs. Similarly, theta 4j which is equals to theta 4s plus delta theta 4 by delta y into yj minus ys. So this it is already explained in function generation, right? So we will so I already explained that. So here, so the values of theta 2s and theta 4s, these are the starting position of input link, and theta 4s is the starting position of output link. So yes, it represents the starting, 2 and 4 it represents the input and the output link. Now let us take also so the value of this delta x. So delta x which is defined as x of final minus x of starting, or initial. So x of final we know 4, the starting value of x it is 1, so 4 minus 1 it is 3. Similarly delta theta 2, so delta theta 2 is nothing but it is a range of the input link, so which is given as theta final minus theta starting, which is equals to 90 degrees. So this he has given directly in the problem, right? So the input crank angle it will have a range of 90 degrees. Similarly delta y, which is nothing but y of final minus y of starting, which is equals to, we calculated this with respect to the corresponding values of xf and xs. So we got there it as 8 minus 8, y of final as 8 and y of starting as 1. So 8 minus 1 which is equals to 7. Similarly delta theta 4, it is a range. So delta theta 4 which is equals to theta final minus theta starting. So in the problem he has given the output link, it varies from 0 to 90 degrees. So 0 is the starting angle and 90 degrees the final angle. So 90 minus 0 degree which is equals to 90 degree. Now you take this equation theta 2j which is equals to theta 2s plus delta theta 2 by delta x xj minus xs. Now I will find out the corresponding the input crank angles, that is 21, 22 and 23. Just I'll substitute the value of j as 1, 2, 3. So if I substitute the value of j as 1, 2, 3, then we'll get the input crank angles theta 21, theta 22 and theta 23. Only the rest of the things are the constants, only the value of xj will changes. Now to substitute the value of j is equals to 1, so this equation it becomes theta 21 which is equals to, so theta 2s, so it is the starting value, that is starting position of the input link. So it is given in the problem 30 degree plus delta theta 2 it is 90 degree, delta x so it is 3 into j it becomes 1, so x1 minus xs. So xs it is 1 and value of x1, so from Chebyshev spacing equation, so we got the value as 1.20. So substitute this, so we'll get the first position angle. So the first position of the input crank angle, that is theta 21 which is equals to 36 degree. Similarly you substitute the value of j as 2, so we'll get theta 22. Okay, so for j is equals to 2, so the equation it becomes theta 22 which is equals to theta 2s plus delta theta 2 by delta x into, so this term it becomes x2 minus xs. So all the terms are constant, only the value of x2 it varies. We just substitute the value of this, so we'll get theta 22 as 75 degree. Similarly substitute for j is equals to 3, so we'll get theta 23, here it becomes x3. So substitute the values, all the values and simplify it. So we'll get theta 23 as 155.95 degree. So these are the corresponding input crank angles for the 3 positions. Okay. Similarly, we have to take this equation, one more equation. So this equation which related to the output crank angles. Okay. So let us you take this equation and you substitute for the values. Okay. So when j is equals to 1, so theta 41 which is so j is equals to 1, so we'll get theta 41, right? So j is equals to 1, it becomes theta 41 which is equals to theta 4s plus delta theta 4 by delta y. So this it becomes y1 minus ys. So substitute everything, so we'll get theta 41 as 4.037 degree. Similarly substitute j is equals to 2, so this it becomes theta 42 and it becomes y2. So rest of the terms it remain as it is. Okay, so substitute it, so we'll get theta 42 as 37.96 degree. Similarly when j is equals to 3, so we'll get the theta 43 as 82.33 degree. So these are the corresponding output angles for 3 positions. Okay, theta 41, theta 42 and theta 43. So therefore the input angles, okay, so the input angles theta 2, so we got the 3 angles. Similarly the output angles, so theta 4 we got the 3 angles for 3 positions. Okay, so referring to this diagram, so this is the 4 bar chain. So the displacement equation, which is given by Freudensteins, so it is given by this equation for this mechanism. So that is k1 cos theta 4 minus k2 cos theta 2 plus k3, which is equals to cos of theta 2 minus theta 4. So theta 2 is the input crank angle, theta 4 is the output crank angle. Okay. So where the value of k1, so which is given as d by a, the value of k2, which is given as d by c, right, and the value of k3, which is given as a square minus b square plus c square plus d square by 2 times of ac. Now you have to substitute the input and the output angles, that is corresponding angles. Okay, so this equation, so which I already explained in previous problem. Okay, so we got again the three angles, that is three input angles and three output angles. So you have to substitute the corresponding input and the output angles, that is theta 21, theta 41, theta 22, theta 42, theta 23, and theta 43. Okay. So if you take the first position of the mechanism, that is theta 21, theta 41, substitute for this equation. So here it becomes 41, 21, 21, 41. Okay. So you'll get one equation. Similarly, you take second set of the angles, substitute for this, we'll get second equation. Similarly, you substitute theta 23 and theta 43 to this equation, we'll get the third equation. Okay. So on substituting all the values in displacement equation, so the three equations, it consisting of the unknown terms k1, k2, k3. Okay. So you solve those three equations. So we will get the value of k1, k2, k3 as, so k1 as minus 0.2838 and k2 as minus 0.199 and k3 as minus 0.9703. So once you get the values of k1, k2, k3, so use this equation. Okay, so k2 it is d by c, k1 it is d by a. So again here, in order to solve this, we have to assume any one of the link in this mechanism. Okay, so let us assume that the length of this link, that is d, which is equals to 1. When you assume d is equals to 1 over here, so we'll get the c, which is nothing but d by k2. So d is now, the value of k2 is minus 1.9. If you simplify this, so you'll get the value of c as minus 5.0. Similarly, you take this equation, right? Already d is assumed, it is 1. So we'll get the value of a. Okay, so you substitute this into these equations. Okay, we'll get the values of a, b, c, d as a is equals to minus 3.52 units, b is equals to 2.07 units, and c is equals to minus 5.0 units, and d is, which is assumed. Okay, so this is what the way of finding the dimensions of the 4-bar mechanism. So for more problems, you can refer the textbook, which is authored by me. Thank you.